Okay, back on the exam review. We're up to problem number 20 here, and it notes that we have a rational function called r, and r is given as this quadratic, x squared plus 5x minus 6, and then it's divided by some unknown function called g. And it says, assuming that g is not 0, so this is non-zero, could be positive or negative, we don't know, but it's not 0. What are the zeros of r? What are the zeros of this rational function? Okay, so let's think about just arithmetic, for example. If you have a fraction and it's equal to 0, you know two things. The first thing you know is that b cannot be 0. The denominator of a fraction is never 0. But the second thing you know is that in order for this fraction to equal 0 together, then the top must be 0. The top has to be 0. So you can think of various fractions like 0 divided by 3, that's 0, right? Or 0 divided by 5, that's 0. But we would never see a fraction 5 divided by 0. That's silly. Okay? Not defined in mathematics, any kind of mathematics. So sure enough, once you understand how fractions work or how rational expressions work, assuming g is not 0, what are the zeros of r? What's the zeros of this whole thing? The zeros of r would be the same as the zeros of the polynomial x squared plus 5x minus 6. And what are the zeros of that? Well, again, zeros are the numbers that make this equal to 0. So now we're back to solving this equation again. Minus 6 is equal to 0. It factors very nicely. You could solve it by factoring. You can solve it by completing the square. You could solve it by the quadratic formula. You could even solve it by your calculator, right? Now make sure you type the right one in. This was the one that we were looking at before, but now we're doing minus 5x and then minus 6, or plus 5x and then minus 6, plus 5x and then minus 6. And here's the graph. It does have a couple of zeros. You could count the tick marks if you want. It looks like 1 and negative 6, right? So the choice would be over here. But if we didn't know that, we could factor it very nicely, right? X plus 6 and x minus 1 is equal to 0. So because we're going to use the zero product theorem, each of these factors has to equal 0. So x plus 6 must be 0. X is equal to negative 6. Or this one, x minus 1 is equal to 0. X is equal to 1. Okay, next problem. Ho, ho, ho. So many people got this one wrong. And I think the problem, of course, was that most people did not know what the log function looked like. And so they were sort of stymied what to do. And many people just jumped on their calculator and said, hey, I can use my calculator and I'll just type in the natural log of x and look at the picture and then choose the right answer. And it looks like this choice here, right? And many people chose, I guess it was D. Many people chose D, which is just wrong. This graph does not hit the y-axis. In fact, if you recall the whole discussion on exponentials and logs, the exponential growth graph was this one here that is asymptotic to the negative x-axis and takes off to infinity. The inverse is the reflection about this 45-degree line. So since the exponential graph goes to the negative x-axis, its inverse would go to the negative y-axis, and it looks like this. So sure enough, this graph does go all the way down. The correct answer was C. And you say, but it doesn't look like that on the calculator, Mr. Bosque. Yeah, but I mean, if I were to trace here, and if I'd say x is equal to 0.1, then I see the y-coordinate is negative 2.3. It's not at negative 2. If I go x is negative 0.01, and then now the y-coordinate's down here at negative 4. It keeps dropping. Why don't you see it? Because the X values are so close to the y-axis, the pixel just doesn't show up. I suppose if we change the window, so we say we went from -1 to 1, and then looked at it, you would see more of the graph going down. But even then, it almost disappears. So maybe if we made the biggest X value, say 0.1, -0.1 to 0.1, and we looked at that, would that be better? Yeah, we'd see more of it going down. But this does go all the way down to -infinity, right? So the choice was C, not D. The other point that, the other 2 points that you should know for sure is this point here, the 0 of the function. So the graph goes through the point 1, 0. And another very nice convenient point is this one here, which is E, 1. And E is a little bit more than 2, right? So just look at your, there's 2 and there's 3. So it's about 2.7-ish, approximately 2.7. Okay. 22 and 23 I put together here. If you have the right picture in your head, these are trivial. So again, let me get a little sketch of the log graph. Remember, it goes all the way down like that, and then it goes like that. And the first one talks about the domain. So the domains are the X values, right? We never get to 0. So we're going from 0 on out. So all reals. And now this says positive, this says non-negative. And some of those folks may think that that's the same. Well, that's not the same. The non-negatives include 0. And 0 is not part of this graph. In fact, if we tried to go back to our calculator, what happens if X is 0? It comes back and says there is no Y value. There is no dot, the natural log of 0. And if we're, here's our home screen. What is the natural log of 0? And it says, sorry, you can't do that, right? It's not allowed for the function, okay? It's not in the domain. So the correct answer here was all positive reals. And 23 was the range. Well, the range is the Y values. And so we know this goes all the way down to -infinity, and this continues to rise. There is no upper cap. So the range would be all real numbers. Pretty easy if you had the picture in your head. 24, what's the 0 of the function? Well, again, here's the picture, right? The 0 is the x-intercept. And in fact, all the choices that you had a x-intercept of 1, right? So every choice that was given here, even the wrong ones, went through the point 1, 0. So this one here should have been easy. The 0 of the function is the x-intercept of the graph, and that's x is equal to 1. Okay, number 25. Let's see. On each problem, exact simplified numerical answers are required. It's designated calc. It's designed to be used with the graphing calculator. We can use the calculator on any problem, but note that this choice B, for example, says X is 20.085537. How in the world would you get that if you did not have access to a calculator? And the answer is you couldn't. So because this is not designated calculator, we've got to solve this analytically or algebraically. My translation idea when I was teaching this in Algebra 2 was that says 10 times 10 is 100. This says 10 times 10 is 100. They say exactly the same thing. This is in the language of exponents. This is in the language of logarithms. We have a logarithm equation here. It says natural log of x is equal to 3. You should know that that's using the base e, right? So log base e of x is 3. So we just have to translate it. Log base e, Joe, of x is equal to 3. So we just translate it and we get e cubed is x. And that is the solution to that equation. Okay, x is e cubed. Okie dokie. Simplify exactly. This is the natural log of root e. I can write that as the natural log of e to the 1/2 power. Remember, 1/2 is the square root. Right? So when we have x to the 1/2, that's the same as the square root of x. Right? So you should remember fractional exponents. And then the one property of logarithms that applies here, this exponent this 1/2 exponent is allowed to be brought out in front of the log expression. So those two things are the same. And then lastly, to finish it, let's see, what is the natural log of E? Well, again, let's go back to the picture again. Right, here was the picture. And we noted that this dot is an important dot. Right? If X is E, then the log of that is 1. So the natural log of E is 1. And you needed to know that fact to clean this up a little bit. Okay, so we got to this stage. Got to this stage. And then the natural log of E is simply 1. So we have 1/2 times 1, which is 1/2. Interestingly enough, you could have done this on the calculator if I just said, what is the natural log of the square root of E? And find the E key. It's way over here by the pi key. Right? And sure enough, you get 1, or you get 1/2, 0.5. 27. Considering the asymptotic behavior of this function. Select the correct statement. You might want to look at your answer to 21 on the previous page. Well, 21 was, again, the graph. So let's just get the graph going right here real quickly. We have this asymptote going down, and then this increases. There is no upper bound to this. This keeps growing very, very slowly. The only asymptote in the picture is this negative y-axis. So the curve gets closer and closer and closer to that negative y-axis, but never reaches it. Okay, so going down to infinity. And if we look at the choices, now this was probably the hardest question on the test because you had to actually understand what asymptotes were. This first choice says the function approaches 0 for positive x values near 0. Well, here's positive x values near 0 down over here. And the function is not going to 0. The function is going down. Right, so that's out. The second one, f is undefined for positive x values near 0, and the answer is no. For every positive value near 0, it doesn't matter how small it is. We could say, you know, what is the natural log of 0.00000001? That's a small positive value, and we get a value. It happens to be negative 18. F is not undefined for positive values, so that's out. F of x approaches negative infinity. These are the y values, approaches negative infinity, or decreases without bound as positive x values approach 0. And that's what's happening. As x comes this way, the y values are heading south in a hurry. Right? So they're going down, 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 down. And this is the right answer. Just looking at the other choices so we can eliminate those. F approaches positive infinity. No, the function never goes up. That would be approaching positive infinity. So that's out. And the last one, F has an asymptote of y is equal to 0. Well, y is equal to 0, remember, is the x-axis. And that is not an asymptote, right? In fact, the curve crosses the y-axis, so that's out. If it said f of x has an asymptote of x is equal to 0, that might be plausible, right? Because this is the line x is equal to 0. But that's not what it said, so that's out. Choice was C. Okay, 28. Well, lo and behold, everybody in the 4 classes got this one right. I guess we can skip that. It does say use your calculator, and it says, what's the natural log of 3? Yeehaw, got it, 1.09. And by the by, you know, you could have actually gotten this without a calculator. My calculator dies, I can't do the problem. That's not true. Here's the graph. Right? Remember, this dot was 1, 0. Here's 2. Here's 3. Here's 4. At 2.7-ish, right, we have another dot right here. This is the point E1. So here's 1 right here. So here's 2. And the question is, what is the natural log of 3? So we know it's very, very close to 1. This is the one that's the right answer. 1.3, you might think, but no, in order to get up to 1.3, you know, the natural log, how far out would we have to go, I suppose? The natural log of x is 1.3. How would you get that, right? That's e to the 1.3 is x. So we would have to go all the way out to this number if we needed to get that e raised to the 1.3 power. Okay, we'd have to go out to 3.66. Okay, number 29. Solve this equation. Let's see how much time we've got going here. Okay, we'll go up to 29. Yeah, maybe a little bit more, and then we'll stop it. Solve this equation, exactly. So 2 plus 3 to the x minus 2 is equal to 6. Subtract the 2. 3 to the x minus 2 is equal to 4. This is an exponential equation. Here's my translation key again, right? 10 squared is 100. It says 10 times 10 is 100. Log base 10 of 100 is 2, says exactly the same thing. This particular equation here is, in fact, exponential. So let me take this and move it. Let's see if I can grab all of this, move it down over here. Okay, so it's exponential, and I just need to translate it. I'll use the translation key to get the logarithmic form. And we know this is going to be a log. The base is going to be 3 of 4 is equal to x minus 2. There, I have translated it. Unfortunately, I did not want to know what x minus 2 was. I wanted to solve it for x. So the last thing we do is move the 2 to the other side, just add 2 to both sides. 2 plus log base 3 of 4 is equal to x. And that's the solution that you should have been looking for. 2 plus log base 3 of 4. Okay. The next few questions deal with cubics. And I think we'll save this batch of problems here for the next video. Okay, so we'll stop this one here at 29.